I want to have a smart alert system that would help. But nowadays, it would be overall comfort. So it's very easier to use as a mask.
Start.
Okay. Yeah. Hello everyone, this is Passkey from 6th GMU. Today we are here to present our project-based learning review 2 of topic named Secure Cloud Access Control with Multi-Factor Authentication. So cloud systems today handle a huge amount of sensitive user and enterprise data, so security becomes extremely important. However, most traditional systems rely on only passwords for authentication. This creates a major issue known as single point of failure. If a password is compromised, the entire system becomes vulnerable. At the same time, cyber attacks are increasing rapidly. Common attacks include phishing, where users are tricked into giving their credentials through fake websites, credential stuffing, where attackers reuse leaking passwords across multiple platforms, and brute force attacks, where systems are attacked by trying multiple password combinations. So overall, password-based authentication alone is no longer sufficient. To solve this problem, our project introduces a multi-layered sequential authentication system. Instead of relying on one factor, our system verifies the user through multiple steps, significantly improving security and reducing the risk of unauthorized access. So the next slide is about system design and architecture. So now coming to the system design and architecture, our system is built using
ಅನ್ನಪೂರ್ಣ ಸ್ಕ್ರೀನ್ ಶೇರ್ ಮಾಡ್ಕೊಂತ ಸ್ಟಾರ್ಟಿಂಗ್ ಇಂದ 1 ಸೆಕೆಂಡ್ ಫಸ್ಟ್ ಇಂದ
first in the hella.
ವಾಯ್ಸ್ ಬರುತ್ತಲ್ಲ start.
Hello everyone, this is Annapurna from 6th GMU. Today we are here to present our project-based learning review 2 of topic named Secure Cloud Access Control with Multi-Factor Authentication. Cloud systems today handle a huge amount of sensitive user and enterprise data, so security becomes extremely important. However, most traditional systems still rely on one password for authentication. This creates a major issue known as a single point of failure. If a password is compromised, the entire system becomes vulnerable. At the same time, cyber attacks are increasing rapidly. Common attacks include phishing, where users are tricked into giving their credentials through fake websites, credential stuffing, where attackers use leaked passwords across multiple platforms, and brute force attacks, where systems are attacked by trying multiple password combinations. So overall, password-based authentication alone is no longer sufficient. To solve this problem, our project introduces a multi-layered sequential authentication system. Instead of relying on just one factor, our system verifies the user through multiple steps, significantly improving security and reducing the risk of unauthorized access. So the second slide is about the system design and architecture. So now coming to the system design and architecture, a system is built using the Django framework, which follows the MVT architecture, model, view, and template. The model handles all the database operations, including storing user credentials and authentication data. The view is responsible for processing the authentication logic. It checks the user's credentials, verifies OTPs, and controls the overall flow of system. The template presents the user interface, which is built using HTML, CSS, JavaScript, and Bootstrap, allowing users to interact with the system easily. The overall flow starts when the user enters their credentials through the browser. The request is sent to the Django server, where multiple authentication layers are applied sequentially. These layers include password verification, OTP-based authentication, the face organization. Each step must be successfully completed before moving to the next, ensuring a high level security. We also integrate external services such as email or SMS APIs for OTPs generation and delivery, and face recognition APIs for biometric verification. The system uses a relational database like SQLite or MySQL to securely store user data and authentication records. This modular architecture provides key advantages such as scalability, meaning it can handle more users easily, and maintainability, making it easier to update and improve the system in the future. So overall, the system enhances security by replacing single-layer authentication with a robust multi-factor approach, making it highly resistant to modern cyber attacks. And the further will be continued by my teammates. Thank you.
Hello everyone, I am Kaustuba, and now I'll be explaining the enhanced authentication workflow of our system. When user initiates a login request, the system dynamically creates a multi-factor authentication queue based on security requirements. The verification process happens in multiple layers. First, the user enters their password or PIN as the initial authentication step. Next, the system performs bot protection using CAPTCHA mechanisms. This can include I am not a robot and verification, image-based CAPTCHA or text-based CAPTCHA to ensure the user is human. After that, the system proceeds with knowledge-based authentication, where the user may be asked security question or required to enter a security PIN. Then the system performs possession-based verification using email OTP or time-based one-time password generated through Authenticator app. For high security scenarios, and additional biometric such as voice authentication can also be applied. Access is granted only after all required verification steps are successfully completed. Importantly, this workflow is adaptive, meaning the system can modify the number and types of authentication factors depending on the user role, login behavior, and risk level of the session. This ensures both strong security and smooth user experience. Moving on to the tools and technology. For the backend, we use Python 3.12 along with Django 5.1, which provides a robust and secure framework for handling authentication logic. For the front end, we used HTML5, CSS3, JavaScript, and Bootstrap 5 to build a responsive and user-friendly interface. To implement multi-factor authentication feature, we use several security-focused libraries. For OTP and TOTP generation, we use PyOTP for handling OTP workflow. With Django, we used Django OTP for secure password hashing. We used Argon 2, which is highly resistant to attacks. For CAPTCHA verification, we integrated CAPTCHA service to support I am not a robot, image CAPTCHA, and text CAPTCHA features. For email OTP, we use Django built-in email backend for sending verification codes. For voice authentication, we use basic audio processing and verification techniques, which can be extended using advanced speech recognition APIs. Additionally, we use Python.env to manage environmental variables securely, and PyTest for testing and validation of the system. All these technology together help us build a secure, scalable, and efficient authentication system. Thank you. That's for my part.
Hello everyone, I am Chandana. Today I am here to explain about the development process of this project. In this, the development process of our project, we focused on building a strong and secure authentication system with multiple layers of authentication and verification. We began by implementing a user authentication system with a role-based access, which allow user to differentiate between admin user and a normal user and restrict the access accordingly. After that, we developed the core MFA factor features. First, we implemented email OTP, which acts as a primary identity verification layer. Then we added the security questions, which serves as a cognitive authentication factor based on the user knowledge. which is of their interest. We also implemented the PIN verification, which provides an additional layer of security using an user-defined number code. Once the core feature were completed, we moved on to the advanced integration, like adding an TOTP authentication using an authenticator app, which is generated based on the time, and also a dynamic OTPs. We also added a voice biometric verification, which introduces a biometric layer by verifying the user voice. In addition to this, we focused on system monitoring and management. We built an admin dashboard that allow administrator to track the user activities and also what are all the system usage done by the normal users and logs. Then finally, in the development, a secure document management feature was also added, and also audit and logging system was added. So overall, in the development phase, we built an authentication layer, adding in multiple factors of MFA, and also with the monitoring capability. Moving on to the next slide, implementation. In this, as I explained the features, and in this we integrated it using a secure and dynamic system. The core important part of this sequential MFA engine is we designed a dynamic MFA queue using a function called build MFA queue, which determines an authentication steps required for each user. If the user is new, the system forces steps like TOTP and a voice enrollment. If an user returning the system dynamically builds a sequential such as email OTP, CAPTCHA, image verification, text verification, PIN, voice authentication, TOTP, and a passkey. We use a Django session to tag the authentication process using a variable called pending MFA user ID. In this, the user is only fully authenticated after completing all the steps successfully. They can't skip any particular point. In next, moving on to the email OTP, we used secure methods to generate an OTP, which is which is of 1 minute. It will be valid. Within that, if they won't enter, it will again need to regenerate. That is a 6-digit OTP using a Python secure libraries. And instead of storing it directly, we store it using a blockchain technology and hashed it. During the verification, the input is hashed and compared securely, and we enforce that. We also added a voice biometrics. We implemented both front end and a back end processing. On the front end, audio is captured using a web speech API. During this enrollment, a voice signature is created and stored. During login, the new voice amplifying is compared with this stored signature using a similarity score. If it matches with a threshold and authentication will be successful. If that doesn't match, re-record that particular voice. For a TOTP, we used a time-based authenticator app, which is by Google, and we assigned a security key, which is scanned using authenticator app. The TOTP will be valid for a 30 seconds, and it will keep regenerates after that particular time limit. For the passkey authentication, we implemented a WebAuthn. That user device generates a public private key pair. The public key is stored in the database, which is built in a SQLite of Django, and a private key remains on the user device. During login, a challenge is signed using a private key and verified using a public key, enabling the secure biometric login. Then we added a one particular feature here is secure document vault implementation, which is a key features where documents can be stored in a user space by user. These files are not served directly through URLs. Instead, we can protect the backend function to serve the files. This function checks whether the user has completed full MFA factors, which is of 8 factors. Only if that 8 factors is successful, then the file is securely delivered to that particular user. This approach prevents an unauthorized access and protects against the attacks in a direct object references. And we also implemented the secure logging and monitoring, because like audit monitoring is one of the important feature, as we need to monitor those, not only storing, and we also need to monitor for unusual behavior, and to monitor the user performance. If a login occurs from a new device or a location, it is flagged as an unusual until they complete all the MFS clearly. Finally, we integrated a voice assistant where a user can navigate using that voice, like giving an inputs like go to home page, or like that, or giving a commands, improving the accessibility and the user experience. will show you that particular webs. This is the home page, and this is what are all the things here in this, and this is exactly the workflow, how it exactly works. As I explained, the primary authentication will be based on the email. User will provide a particular email, and for that email an OTP will be sent. Based on that, they will provide that 6-digit OTP, and we have added some of the, like I am not a robot and CAPTCHA, image CAPTCHA, and also text-based CAPTCHA, and a private question will be asked during the register that will be given, and a secure PIN access, whether it might be a four character or eight. Then we have added a voice biometrics, which will be based on the threshold and similarity score, and an authenticator TOTP, and the hardware passkey will be stored on that particular user device. We will get an OTP. After that, we will get this. After that, we will get an image check. This will be asked when the particular user registers, and that will be used the login, and the PIN also. As here in the voice ID MFA, here a particular phase will be given. The user must record their voice sample here, and during the register also they will here the same will be video also. That will be stored in a .wav file. Safety account secure network. Here we can see that it is stored in a .wav, and it will verify. Then we will get a TOTP, which is based on the Google Authenticator app. As here I have given a voice. Here they can start voice. Go to home page. Then we can stop it. That will, and here we can see what are all the logs. The feature, this is that adding the files, so that a particular user will get these files after completing all those MFAs. Here they can upload a new file also from their system. And also here the profile tab is there, and what are all the logs. As here I am logged in as an admin, so I will get to know what are all the logs, and from like with the timestamp and the detail, and what are all the devices they will be given with the IP network. That for my part, further will be continued by my teammates.
Now I'm going to explain the testing and validation. Password hashing, we verified that user password are not stored as a plain text but securely encrypted using hashing algorithms. This prevents a data theft even if the database is compromised.
ಪ್ರಾರ್ಥನಾ mic.
ಹಾಗಿದೆ. ಈಗ ಟೆಸ್ಟಿಂಗ್ ಅಂಡ್ ವ್ಯಾಲಿಡೇಷನ್. Testing and validation. Unit testing. Password hashing, we verified that user passwords are not stored as plain text but securely encrypted using hashing algorithm. This prevents data theft even if the database is compromised. OTP generation and expiration. We tested whether OTP are generated correctly, sent to the user and expire within a fixed time. This ensure the secure multi-factor authentication. Integration testing. In integration testing, we combined all modules like login, OTP, verification, and database operations. We simulate the complete login process from entering credentials to OTP verification. This ensure smooth communication between the front end and the back end and the database. System testing. The system testing, we tested the entire application as a whole. Role-based access validation, we verified that different user like admin and normal user have different permissions, and for example only the authorized user can access the sensitive data. Non-functional testing, this focus on performance and security rather than features. Security headers, we checked HTTP security headers to protect against the attacks like XSS and click hijacking. Response time performance, we measured how quickly the system responds to user requests to ensure a smooth user experience. Results and analysis. Unauthorized access blocked. Our system prevented access even when attackers had a correct password but failed OTP verifications, moving strong security. 100% login traceability. All login activities were recorded in audit logs. This helps in tracking user action, useful to detecting suspicious activity and improving accountability. Improved accountability and monitoring. Admins can monitor all the activities in the system, making it easier to manage and user and detect misuse. And efficient performance, the system handled multiple users at the same time without slowing down. This proves scalability and real-time usability. Voice assistant enhancement, we integrated voice assistants to improve user interaction, help user navigate securely, useful for accessibility and of use. And our testing proves that the system is secure, reliable, and performance efficiently under the different conditions. It successfully protects user data and safe authentication. Next will be continued by my team member.
I am Priyanka. Now I am explaining about the conclusion of this project. This project demonstrates how sequentially multi-factor authentication strengthens system security by adding multiple layers of verification instead of relying on just one step. By doing this, it reduces the risk of the single point failure, meaning if one authentication factor is compromised, the system still remains protected. Overall, this approach improves security, reliability, and user trust while still maintaining a balance so that the system remains easy to use and not overall complicated for users. Next, future scope. For future improvements, we plan to focus on enhancing the user interface and user experience to make the system more user-friendly. Additionally, we aim to improve cloud deployment and hosting, which will allow the system to scale effectively and be used in real world environment with better performance and accessibility. Thank you.
Done, everyone? Yes, ma'am. You had shown that uploading the file or template, how it is secure and overall allowed to access those files.
Ma'am, can you repeat that question, ma'am?
You had shown that file now, you are uploading the file.
Yes, ma'am.
After all the authentication verification.
Yes,
Hello.
ma'am. Like after completing all those MFA
Yeah.
factors, what I showed,
Uh-huh.
then only
It
they
can
can
be accessible by everyone.
Yes, ma'am.
Overall allowed to upload those files means every user.
Here we have a two roles, ma'am. One is admin and the one is user. Admin, what admin will do is they will monitor the logs and auditing. Even they will have a control of what exactly the user is doing. Even admin can also upload the files. User can also upload the files. As of now, I have given those permissions. But the admin will have a like overall superiority of what are all the things user is doing, but user will only get to like upload the file, view, and they will have a crude operations like to add the file, delete. If they want to modify it, they can modify, but they won't get to know like what others are doing or like audits and monitoring. They won't get to know.
Is it secure?
Yes, ma'am, because it doesn't depend on only one single authentication method, and it uses multiple layers. So, which makes it very difficult for an attacker to gain access, and nobody can access others anyway. So, we use all of that. No, ma'am, that's why it is more secure.
What if phishing attack happens in case of?
Ma'am, even if the phishing happens, is because our system is still protected because we don't rely on a single particular authentication. We use it. One is the email OTP and another one is the TOTP. TOTP is valid only for 30 seconds, which is like a split of a minute. So in that particular time, nobody can't trace, and it is also based on the user authentication. Like for an authenticator app, also there will be an authentication. If even they want to steal the user password through phishing, they still can't access their account like based on the sequential of MFAs, that is pin question or a pin and a voice also, and even a TOTP.
What is hijacking? You have mentioned, I think, in the previous slide.
No, it means like the attacker will try to take
That is
over
a
the
session
user.
hijacking. Like we have added a multiple protection to reduce that particular risk. Like we use a Django session secure management, while it stores a session ID and cookies in that particular session flag, like HTTP only and secure. It prevents the access through the JavaScript and ensures the transmission over only through HTTPS, which is secure. And the user is not fully authenticated until all the MFAs are completed. So, and we also track the session variables. Even if the particular session is partially hijacked, it cannot be used to access the protected resource which are being stored in that particular system. Like we have added that session expiration and regeneration using Django's inbuilt functions.
Right. Then what you people will decide to implement this, like in website dashboard or any cloud access?
As of now, I went through some of the as we discussed it. I went through some of the cloud platforms, and to make it like overlay on that particular cloud platform, it is asking for an SSL certificate, and which is also cost based, and we need to own our own particular server. So we thought of doing it like a MFA for a particular document access to store the important documents. So we thought of changing the project title and make it as a cloud secure document access using MFA, so that we can make it as a website.
Yeah,
After all the
website
MFAs
dashboard.
will complete, we will get a document access.
Okay, pa. Anything else?
No.
Yes, ma'am.
What? Chandana,
Yes, ma'am.
what you have?
Nothing, ma'am. If you have any questions, you can ask, ma'am.
No, my side is done.
Thank you, ma'am. Let me end
Okay,
the session.
we'll end up.